Alright, 17 is asking you how many NAND. Some students, I think they have confused with AND and NAND gate, okay? So it's asking you how many NAND gates will be required to perform the OR operation if two inputs are required, yeah? So if we had OR operation, we just have two inputs, A and B go in, and you will get your output X is going to be A plus B, yeah? The textbook like to go with your Q thing here, right? But I like to go just go X is fine. Doesn't matter what variable you use, it's the same thing as your output. So here we have to use NAND gate. So I draw it with the red for AND and a little, alright, negative, a little circle right there. So that's not. So therefore these are NAND. Okay, I'm gonna use 3 of them. So theoretically, we'll be using the De Morgan's. So first input is going to get into NAND, and your X1 is the first input's output, yeah? So here is, when A goes into this gate, A is going to come out, alright, A prime or A bar, which is not A. B goes in and come out not B, yeah? And then it's going to go into the next NAND gate. And I think some of you are imagining NAND as AND. Yeah, this is not AND, this is NAND. So there is a negation right there, okay? A not is right here. So therefore from here we have not A and not B, okay? When they go into the NAND, it's going to cancel out each other, yeah? So when you go into AND here, you're going to get not A and not B together, which is this guy, all right? And that is actually equal to A or B, the whole, all right, prime. So not A or B, yeah? And that's happening at this state, okay? But then we have another not here, and that not is going to cancel this, all right, not. So you're going to get, so up to here is kind of like this, okay? So that's the equivalent of not A and not B is actually A or B prime, okay? If we want to draw it, okay, in a bar, you can be able to draw it like, let me get the little, right, bar here like that. But after you pass this little blue circle, this, right, is going to become like that. Yes. So I'm gonna just write it really fast for you. That's of course your A. It's gonna become double bar right there, okay? So double bar is actually equivalent to your X, yeah? And which is A plus B, yeah, because they cancel out each other. So make sure you have a little circle right here, you know? I draw it with a little blue color here, yeah, so you can be able to see. I think some student is like confused between the regular AND gate and not AND gate, yeah. I usually say not for some reason, so I don't forget to negate what I got by adding them, yeah, here. So this is you are joining them, x1, x2, which is your not A and not B, okay? Alright, so the answer, okay, right here, we will be using 3, okay, we will be using 3 NAND gates as an equivalent to your OR gate, okay? Of course, this is a simpler circuit, your IC, and this is a little bit of bulky IC, so of course we don't want to use that. Alright, so that's for the answer for 17.